So this is my third incarnation here at this conference. So I started out as a Navy captain and program manager at DARPA, so was wearing a uniform. Then I was at the Department of Education as a part of the Obama administration as the executive director of STEM, and now this is my current life outside of government, my first foray in 24 years. And one of the reasons I left DOD and came over to the Department of Education was to actually do a deep dive and look at different ways of developing education technologies and supporting STEM and other areas in education. From my experiences in the DOD, I came to the conclusion that the way we develop ed tech is a bit broken and not the most efficient way of doing it. And so we started thinking about applying some of the lessons learned at the Defense Advanced Research Projects Agency, DARPA, into this space. So what we really want to do at this point, and what I came into the Department of Education for, was to really try to create an organization that really tried to tackle seemingly intractable problems. So the types of problems that we've wanted to try to solve with education technology and in the education community writ large for decades and haven't really achieved the success we were looking for. And so we want to, on the first step, identify bold innovation challenges or moonshots and really change the lives of students. So not just incremental changes, but those types of changes we're looking for that actually will reach every student and really, provide not only a change in their lives, but in the communities around them. Part of the idea here is to fund things a little differently. So instead of funding individual groups, as we do typically in government and even in philanthropies, what we would really be using is what's known as a pull strategy to pull the best talent from across the nation or around the world into these teams to solve these hard problems. So really developing interdisciplinary teams, including people who are not normally in the education realm, but have critical expertise that we desperately need to tap. And so it's a pull strategy rather than a push strategy, including, of course, educators at every step in development. Another lesson I learned at DARPA, which I know we were discussing this yesterday in some of the sessions, but privacy baked into the DNA of the process. So really start out the discussion with privacy, look at what data ownership really means, what security and privacy really mean, and how we actually move forward with ed tech while respecting the rights of students and parents. And the critical part of this is that it's a different type of research. So it's really a basic research process that aims at transformative change. I'll talk about this in a little bit, but this is within Pasteur's quadrant, it's called. And it's an interesting concept. Instead of doing the way we typically do things in government, between basic and applied research, what we say is we don't know the answers to these questions starting out, many of them. And it may not make sense to discuss. So what we do is iterative basic research towards an applied goal. So the basic research feeds into the application, but what's being learned in the application feeds back into the basic research. So it becomes a looping process to try to work your way towards a major goal. I already said most of this, I think, but again, we're want to fund challenges, not specific projects or products. We would like to include foundations, VCs, and other funders. Now, we originally tried to do this in government. Congress would not approve it over the 8 years of the Obama administration. By the second year I was at the department, I decided probably philanthropies and outside funding was the way we were going to have to go. And when Jim Shelton, who was the man who recruited me to the Department of Education, left and then eventually took the education slot at Chan Zuckerberg, things started to align with maybe getting something done outside of government. We see projects transitioning in three ways. One, feeding into specific programs sponsored by the funders, so try to solve problems that they've been having trouble solving themselves. Products directly to classrooms, and potentially even open source solutions that could be distributed out to the developer community writ large. So if you're not familiar with DARPA, how many people do not know what DARPA is in the audience? Anybody? Oh, good. That makes it easy. But so we are trying to model somewhat over the DARPA process, but really adapting it to the unique needs of education. DARPA has the advantage of having a market at the end of their development process, so the DoD is likely to buy what they produce if it works. But as you can see down below, a lot of things have spun off into the civilian community, including Siri, various robotics, vaccine breakthroughs, and a lot of things that affect us on the internet and personal computing. So a lot of things going on through the DARPA process. And one of the things I tell people is even when the DARPA programs fail, and quite often they do fail, they are riskier investments, there are spin-off technologies. So, for instance, Siri was not really the exact product or the exact path that DARPA was going at for their program, yet this spun off and had a big impact in society. So the process of this iterative basic research process towards the boldest challenges really can have not only foreseen but unforeseen impacts in the education community and elsewhere. And again, this is the Pastor's Quadrant discussion. And again, I'm a behavioral scientist by training, so I'm an experimental psychologist. And one of the things that I keep preaching to everyone is that the basic and applied research distinctions don't really serve us well in the behavioral sciences, including education. Basic research, again, and behavioral science research writ large is very noisy. It's very context-specific. It doesn't generalize well. So when we have this basic applied distinction, quite often when we start building an application based on basic research, it doesn't work. Because the basic research that we're making our assumptions off of doesn't really apply to the situations that we're building towards. So our idea is to try to collapse that. It means you have to have more investment on the front end of it to be able to do basic iterative research towards applied goal. But there is less of a disconnect between the basic and applied research areas. And ultimately, I think you'll learn more about the topics you're seeking. What we're really thinking about as well is 3 innovation models, DARPA being the main one, but we're also looking at Incutel, which is the intelligence community venture capital fund. So it's kind of a federal version of a VC that looks at existing products and how to adapt them to meet the needs of the customers. So rather than inventing everything from the beginning, we realize there are good products out there. They may not be optimal. They may not work as we want them to, but they could be adapted if actually integrated into a larger program. And so we'll be looking not only at new technologies, but existing technologies that could be adapted and fixed and improved to go into the community. The other thing that I'm very strong on is the need for a skunk work. So what our research funding does today very well is basic research funding. It typically does not put enough money in to actually create a professional product. And that's a problem, because if you're doing your research based on a product that is not well designed, your research doesn't really mean much. So it's based on the faulty assumption that the poorly designed education product that you're testing actually is representative of what a final product would be, and it typically is not. And so what I would like to do is actually see more funding given to the developers, who are really the creative powers in a lot of this, to really design professional level software, but also give them the leeway to actually innovate in their own rights, which we typically today do not do. This is how we bound problems at DARPA. And it's really answering these how questions. But again, I think the one that I want to impart most is, what are you trying to do? Articulate your objectives using no jargon. And that's a big part of what we really push in this type of thinking. If you can't discuss what you're trying to do without using jargon, you don't really understand what it is you're trying to do. And again, how is it done today, and what are the limits of the current practice? So these simple questions, seemingly simple questions, actually help you break down the problem you're trying to solve. And so when we're right now in the process of identifying major problems we want to tackle, we're actually talking our way through this list of things to try to identify what the major challenges are that we would like to tackle first. And at this point, we've had 3 expert panels since August, and to expand this out a little bit, we are working regularly now with the Gates Foundation and Chan Zuckerberg working together on this concept. So we're having senior meetings on this weekly. We're developing a business plan. It has not been approved finally yet, but we are working on it. So right now we're still in the problem identification stage and developing our overall business plan for what a private organization like this would look like. But this is how we would actually bound our programs. It's a little different from DARPA as well. So again, what we want to do is have an ultimate vision. So the North Star on this is really, in a perfect world, where would we like to be in 10 years or 20 years? And how could we accelerate to get there in a 4 to 5 year series of programs? So how do we accelerate that North Star? And a North Star might be, kindergarten readiness or some large goal that we want to set out there. In the STEM education realm, we know 50% of our students don't have access regularly to calculus and 33% in courses like physics and chemistry. How do we fix that? How do we get students access to the teaching materials and instructors that they don't normally have access to? So that might be a North Star to say, we want to fix that problem. How do we do that? And then what you do from there is start breaking that problem down into program areas, so these ARPA Ed goals. Breaking it down into major programs. Those programs would have various projects within each program. And then we'd look at interdisciplinary technical areas below, and that could be neuroscience, it could be big data analytics, it could be artificial intelligence. And we'd have these teams from across the nation or around the world working together on these problems, feeding into these projects, feeding into the programs to try to solve the North Star problem. And so it's a different way of actually designing a process. So multiple people in the technical areas could actually be feeding their knowledge into various projects in this team, and these projects might even have overlaps between different programs. And so basically it's kind of an all-hands integrated approach to solving major problems.